11, Standard 10, Subject Maths, Chapter number 3, Linear Equation in 2 Variable, Part 3. In previous video, you have learned how to represent a pair of linear equation in 2 variable in algebraically and graphically. Okay, so in your homework question number 1, you might have observed a graph. Okay, so that is a graphical representation. Now let's take exercise 3.1, question number 1. Question number 1 says a coach of cricket team buy 3 bats and 6 balls for 3,900. Okay, so here we just solution. The cost of ball equals to XRS and cost of bat equals to YRS. Okay. So a coach of cricket team buy 3 bats and 6 balls. So I can represent this way: 3x and 6y equals to 3,900. Okay. Later, she buy another bat and 3 more balls of the same kind for 1,300. So 1 bat and 3 balls. So x plus 3y equals to 1,300. So the question says represent the situation algebraically and geometrically. See, this way, this is the algebraic representation. Now geometrically it means you have to draw a graph of these two lines. Okay, so in your homework you have to draw a graph. Okay, because you need more practice to draw a graph, how to draw a graph. Okay, so the graphical representations you have to do in your homework. So homework graph. Okay, now question number 3. So I'm just representing algebraically so that you can tally your equation with this equation. Okay, if equations are correct, it means you can form graph easily. Now, the cost of 2 kg of apple and 1 kg of grapes on a day was found to be 160 rupees. After a month, the cost of 4 kg of apple and 2 kg of grapes is 300. Represent the situation algebraically and graphically. Okay, so cost of apple equals to XRS and cost of grapes equals to YRS. Okay, so the question says 2 kg of apple and 1 kg of grapes. So 2 kg, 2x plus y, that is 160. Okay, after a month, 4 kg apple and 2 kg grapes. So 4x and 2 kg grapes, 2y equals to 300. Okay. Now also you have to draw a graph of this 2 equation. That is in your homework. Okay. Now let's move toward to the next topic. See, graphical method of solution of pair of linear equation. Now in exercise 3.1 we were not talking about its solution, but we thus understand how to find its solution. Okay. Now graphical method of solution. Okay, in this exercise of in general form, not in general but in specific format, we can write it's independent consistent solution. Okay, so you can write over here if that is intersecting line has unique solution. Intersecting line has unique solution. It means only one solution. So we call it, it's a consistent. So it's independent. Consistent pair of equation. Why I am writing over here independent consistent pair of equation? Because see, why I am saying independent? Because both lines are independent. Okay, they were giving solution. Okay, but both lines are independent because see, each and every point on a line is a solution of that line only. Each and every point on that line is a solution for this line only. It means both lines are independent. Both lines are independent. Okay, but only one point they have common. It means we found a one point. Okay, we found a one solution for that pair of equations. It means these lines are independent, consistent pair of equation. Consistent. It means consistent. It means it's not changing. Okay. So for intersecting line, we can say that has a unique solution. Okay. So what is the condition for consistency? Condition for consistency, it is independent consistent. Okay, independent consistent pair of equation. Okay, independent consistent pair of equation. Now the second thing we have learned that if my lines are parallel, it means they were not intersecting. It means we were not getting any solution for that. So it is inconsistent pair of equation. So that is parallel line has no solution. So it's inconsistent pair of equation. Inconsistent pair of equation. Now, the next thing we have seen that it's a coincident line. Coincident line. In that coincident line, it means two lines are overlapping. Two lines are overlapping. So coincident line has how many solutions? Infinite. Infinite solution. So it's, look at over here. When we say it has solution, it has consistency. Okay. Now, what is the next? How can we identify that equation is my that lines are my coincident line or intersecting line? One thing that is, it's a dependent coincident. It's lines are depend on each other. Depend on each other. Okay. If one of the values are not getting the same to the another one, it means again we cannot say this one is the coincident line. Okay, so it means in a coincident line, both lines are depend on each other. That's why what is the condition for consistency? That is, that are dependent consistent pair of equation. For intersecting line, it's independent. Both lines are my independent. Okay. So these are nothing. All these 3 points you have to keep in mind. All these are a condition for consistency. Okay. All these are condition for consistency. So condition of condition of consistency. All these 3 points are my condition for consistency. It means some opinion for that particular pair of equations. Okay, so that opinion will not changing. That's why we are saying a condition for consistent. It's consistent. So intersecting line has one solution. Okay, so we can say one solution. So we can say that it's a independent consistent. Now the parallel line were not intersecting, no solution, so it is inconsistent. It is inconsistent. Now the third thing we have a coincident line. Which line? Coincident line has how many solution? Infinite solution? No solution. Infinite solution? It means it's a dependent consistent pair of equation. It's a dependent consistent pair of equation. Okay. Now let's just observe all these 3 questions. Okay. So let me do this. So number pair of line and A1, A2, B1, B2, C1, C2. Now comparison. Compare. Okay. Now just write in your ratio form. So I'm getting 2/4. That is 1/2 only. So 3/6. I'm again getting 1/2. Minus 9 upon minus 18. I'm getting 1/2. It means I have found that A1 upon A2 is equals to A2 upon B1 upon B2, C1 upon C2. So all when I found ratios are same only, it means all these both lines are my coincident line. Coincident line. It means how many solutions for coincident line? Infinite solution. Okay. Now the third one. So condition for consistency, we have found that, okay, now when lines are intersect, we have found that the ratios of that lines are A1 upon A2 is not equals to B1 upon B2. Okay, ratios were not same. Now, for the second thing we have seen, that is my coincident line. Coincident line. So, the coincident line we have found that it means both lines are overlapping. It is A1 upon A2 is equals to B1 upon B2 equals to C1 upon C2. Now, for a parallel line, we have found that A1 upon A2 is equals to B1 upon B2, but it's not equals to C1 upon C2. If in your exam asked, okay, so this might be asked in a MCQ or fill in the blanks type of questions. Okay, so if the question asks, two equations were given, then tell whether these lines are intersecting line, coincident line or parallel line. You were not drawing a graph of, okay, what you are drawing, what you are so this three things is very important to solve some MCQ type of questions. Okay, if the questions were asked that two equations were given, okay, and say whether these two equations are my intersecting lines, coincident line or parallel line, you are not drawing a graph. Okay, it's a very lengthy method. What you are going to do, you just compare its coefficient, okay, and you just compare its ratio. After by comparing the ratio, you found one relation among all these three. Okay, from this relation, you can say that this one is my parallel line, and for the parallel line there are no solution. Coincident line they have infinite solution, and intersecting line they have one solution. So you have to remember these three things, okay, to solve MCQ. Okay. Now move towards to some questions. So the questions, check graphically whether the pair of equation x plus 3y equals to 3 and 2x minus 3y equals to 12 is coincident. Okay, if so, solve them. Now look at one. See, the question says you have to check graphically. It means you have to draw a graph. If the question says check whether these two equations are coincident or not, okay, so what you are going to do, you just compare the ratio and just identify if it's intersecting, it means the ratios are not equal. If it's parallel line, two ratios are equal, matlab A1 upon A2 and B1 upon B2 are equal, but C1 upon C2 are not equal. Okay, now it's coincident, it means all these three ratios are equal. Okay. Now the question says we have to check graphically If I take x equals to 0, what I am getting by 2? Okay, x plus 3y equals to 0. Now, if I am taking x equals y equals to 0, I am getting x equals to 6. X equals to 6. Now, if I take x equals to say y equals to 2. Y equals to 2. My x is equals to again 2. Okay. Now, 2x minus 3y plus 12. X and y. X equals to, if I am taking x equals to 0, what is my y? Minus 4. My y equals to 0. So what is my x? Plus 6. Okay. So if I take x equals to 3, that is 6. Okay, so 6 goes this side. Again I am getting plus 6. Plus 6 divided with minus 3. I am getting minus 2. Minus 2. Okay. Now draw a graph. So while I am checking this points, I have found that 6 0. It means I am getting